Oh, there we go. There's the bell. All right. Okay, all right, here we go. So let's see. Here's the do now. Okay. So do that, press pause, and then we'll come back and go over it. Okay, all right, so here we go. So now here, there are two shapes here. All right, I don't know if you see that. Actually, you can go three, actually, as a matter of fact. So here, I could go just as easy as placing a line here. Right, and here I would have a square plus a trapezoid. So let's go that way first. So here we got a 2 by 2. So that makes that 4 units squared. And then what about the trapezoid? What's the area of a trapezoid again? Yep, base 1 plus base 2 times height, right? Divided by 2. So base 1, 1, 2, 3, 4, 5, 6, 7, 8. Is that right? 1, 2, 3, 4, 5. Yep. The height, 1, 2, 3, 4, 5, 6. That's 48. So let's say 48 plus 4, that's 52, right? And then now there's another way of looking at it. I'll show you what it looks like, but I won't actually solve it with you guys. So here you can have, I mean, there's multiple ways you can do this. Here you can have a square here, and then here you can have a rectangle, and here you can have a triangle, right? So now, why would that be necessary? In the event that you forget the area of a trapezoid, what I'm trying to suggest is that there are different ways of going about finding the area. Now, what you cannot do though, you cannot count boxes here, actually. All right, I'll tell you why. Because you can't count the boxes here. Like, you wouldn't know how long these boxes are, and you do need to know them. So don't try to count them, okay? Like, it's just like, that's just not gonna work. It won't be accurate, okay? All right, let's see. What is it? Unit 8, day 22. Let's see, June 3rd. Homework's online, okay? You're gonna get a quiz on Friday. Announcements. Let's see. Thursday. So Thursday's Brooklyn Queens Day. All right. So historically speaking, all right. So meaning not this year, not this Thursday. Historically speaking, students get a day off. All right. Actually, historically speaking, teachers used to get a day off too. So students get a day off. All right. But obviously, given the circumstances, you guys don't have the day off. So, all right, story time with old man name. All right. So, once upon a time, New York City was divided into 5 boroughs. I don't think you guys are like surprised by that, right? And so each one of these boroughs is actually its own city. So that's why there's like a downtown Brooklyn, right? Like, I mean, you know, city has a downtown, right? So each of these 5 boroughs were its own separate, like, how do I say, municipalities? Let's just put it that way. So many years ago, I don't remember how many years ago now, the city of New York decided to, you know, incorporate, right? The city of New York. When I say the city of New York, I mean Manhattan, right? Decides to incorporate all 5 boroughs together as New York City. And I think, all right, if I'm incorrect, correct me. All right, you guys can do some research. Part of the thing that when we were going to, I mean Brooklyn, were going to join the rest of the boroughs as one city, was that we would have a day, all right, it's like a day of like commemoration, all right, of that day when we were incorporated or something, all right, and that was called Brooklyn Queens Day. So back in the day when I was in high school, I believe when I was in high school, I went to high school in Brooklyn. We would get this day off, and I think the kids in Queens would get this day off. But somehow, like kids in Manhattan, Staten Island, and the Bronx, like they would have to go to school on that day, I believe. So, or like there's or something like that. I gotta look it up, man. All right. So, anyways, so long story short, you guys used to get this day off, but not this year. All right. That means there's gonna be work. All right. That's why I'm telling you this. So I'll post work as usual. All right, on Thursday, and then we'll go from there. Okay. All right. So let's see. I emailed the grades to your parents already. If you want to know what missing assignments you have, let me know. Okay. That's it. Okay. All right. Let's get to the lesson. So yesterday we were talking. By the way, I forgot to mention. So I had you copy this, but I forgot to explain this to you yesterday. And that was the word complex composite figure. So composite means putting two or more things together. Okay, so like a composite metal, right? Like, didn't we talk about this, like composite numbers? Right, we talked about that at the beginning of the year, right? Composite figures, right? So like, for example, like rose gold, it's a combination of gold, right? Regular gold and copper, right? So it gives that like really nice looking color, right? It's the same thing as saying complex, which means like, more than one, all right? It's not the textbook definition, but it's close enough. So what I was trying to say yesterday is when you have a complex, or rather a composite figure, you don't have just a single figure that you recognize. It's a combination of various shapes that you've seen before. And then by recognizing what those shapes are, let me write that down. How about that? You have to recognize the shapes. 2 is you have to know the formulas, right? And then 3 is you have to find the area. The areas, actually, right? Because there are more than one shape. So that's the go, okay? So today let's continue. So this is where we left off yesterday. So today we'll do more of this. Let's see. All right, so I did that already. Okay, so here's what we'll do. We'll do these 3 and then another 3 today. I think that might be all the time we got. All right, let's see how we're doing on time early. Yeah, all right. So let's see now. Let's do 2. I'll let you do this next one, okay? Okay, all right. Oh, and then you should watch a video from was it Khan Academy? Was it Khan Academy? Yeah. All right. Okay. Here we go. So here we got this slightly weird L-shaped, right, shape. So the question is, how should we cut this up? Okay. Now sometimes you could separate these shapes in various ways. So now I've not done this yet, so I'm gonna try it both ways. Okay, so let's say we cut it off this way, right? So that means now we have 2 rectangles. So let's see. So here we have a 2 by 4, so that's 8 centimeters squared, right? That's the area. And here we have a 10 by 3. Wow. Okay. All right. That's 30. So the first way, method number 1. It was, what was it? 38, right? 38 centimeters squared. Now, there's another way of doing it. Here we got another 2 rectangles. So having said that, this is 2 times 7, that's 14. And what, okay, so this is 8, right? You see that? This is 8 times 3, it's 24, right? So what is that? Yep, 38 again. Right? So that's how you do it. Okay, now, it's not always so, like, obvious. So, for example, like, one of the numbers they didn't have to give you was the 4. Why? Because based on what we looked at yesterday, up here, if this was 7 and this is 3, the rest of this had to be 4. So they didn't have to tell you that this is 4. Okay, but it's fine. It's very nice of them. All right, let's do one more. Now let's see, I'm gonna cut this off right here. Okay, now what does that mean? That's 7. Now that's 7. This is 3. This is 4. Oh, this one's great. If we do it this way, this one's fantastic. Because the question is, how long is this? Meaning, how long is this, right? Because these two widths of this triangle are the same, right? You see that? So here's the question. If this is 4, and this is 3, and this whole thing is 9, how long is this one right here? Can you figure that out? Yeah, right? You take the 9, you take away the 4, you take away the 3. What are you left with? Yeah, 2, right? So this would be 2 right here. So that means this would be 2 right here. Got that? Okay, all right, let's clean this up a little bit. So that means for that little rectangle, we would have 7 times 2, so that's 14, right? And here for this bigger rectangle, it's 9 times 6, right? That's it. 9 times 6 is what? 54. So what is that? Is that 68? Yep. Okay, yeah. Now, there's a second way of doing it. It's a slightly more work, but let's give it a try. All right, see if it works. So I'll keep the answer here. Let's see. Now, can it work? Yeah, I think it can. Let's give it a try. You see that? Now I have 3 rectangles. Okay, so 4 times 6, 24. 3, now this is 6, right? If this is 6, that has to be 6, so 3 times 6 is 18. This is 9, but we talked about this earlier, right? Wait, hold on, what? This is 9, so this was 2, remember that? And then this is 7. Oh, wait. Oh, I got it. All right, so this was 2, we determined that already. This is 7, but we don't want this. We want this whole thing. Remember that? So this is 7, this is 6. That means this is 6. Right now, man, I hope I'm right. So 7 plus 6. So this whole thing is 13. Where do I write this? If this whole thing is 13, that means 2 times 13 is 26. Does that add up? Wow, I don't think it is. Is it? This is no, I'm right. Okay, because I'm looking at this 24 plus 26 plus 18, right? So 24 plus 26 is 50. 50 plus 18. Yeah, 68. I'm right. Yeah, they're both right. Okay, so now, even though I said that there are different ways of solving this, I think by now you can see for yourself that sometimes different ways of doing it means that there are different levels of difficulty. You know what I'm saying? Like, because remember when I first did this, it was super easy, but then like the second time, like it's just a lot more steps, all right? And the more steps you have to take, right, the more mistakes could be made. So so having said that, what's like a good assumption to have when it comes to dividing these shapes? And I would say this: divide the least number of shapes possible. So you see how here I have to divide into 3 different shapes. If you did it when I first did this, where it was just 2 shapes, I think it would decrease the complexity of doing it. Okay, so again, if you can help it, don't make too many shapes. Make the minimum amount of shapes, separate shapes necessary. Okay, all right. Now, with that said, press pause, try this one right here, and then afterwards, I'm gonna just go over it with you. So go ahead and press pause. All right, and we're back. So let's see. Now, initially when I saw this, I already know I can go like this, right? I can go draw 2 horizontal separators. I could draw 2 vertical separators. So right now I'm actually looking at this trying to analyze this and see which is the better way. Let's see. All right, you know what? Doesn't matter. I'll try both ways. All right, because I have a feeling many of you did it like different ways anyways. Okay, so let's try this way. Now, if this is the case, this is 4 by 6. So that's 4 times 6, 24. Now, let's see. Okay, I'm looking at this right now. That's what I'm doing. I don't want you to think that I'm like eating like Cheetos or Doritos. Like while I'm just like, slacking off. Okay, all right, let's see. So this is probably 6, all right? Although I'm hesitant to write this because I'm hesitant to just assume anything. So this is 3 by 6, that's 18. Right? The question now is this. What about this one right here? Right? The 20. Right? Because you want to see this rectangle, this really long, narrow rectangle. So 20 times what? So here's the question. Like, how long is this little piece right here? Right? So how can you tell? Well, if this is 11 and this is 6, what's left here? What's left here? Right? Think of it like that. 11, 6, yeah, this is 5. So this is 5. This is 5. So that means, let me clean this up a little bit. So this is 5. So that means this is 5 times 20. That's 100. Let's see. 100 plus 18 plus 24. What's 18 plus 24? Let's see. Yeah, 142. Is that right? Okay. Now, let's try the other way. I'm going to go like this. Let's see if that... One, let's see if it works. Second, does it actually make it easier to do? All right, so here we got 4 by 11, right? 4 by 11 for this guy right here, that's 44. 3 by 11, right? See that? That's 11, that has to be 11, right? 3 by 11 is 33. And then the question is, what about this guy right in the middle, right? So that's, oh, this is good. Okay, look. If this whole thing is 20, let me do a better job of this. If this whole thing is 20, by the way, this is how like architects do it. Okay, so if you ever go into an architecture program in college or even at like somewhere like Brooklyn Tech, all right, this is what your teachers are going to expect you to do. So here, if this whole thing is 20, right, this is 4, this is 3, I'm not doing anything crazy here, right? What's the rest that's here? Okay, so this is 20. That's take away 4, that's 16. Take away 3, so that's 13. So this guy's 13, right? So let me clear that up a little bit. Now, what does that even mean? I need to know how tall that is. Well, we talked about that already. This is 5, right? Yeah, we just said it. Am I right? Yeah, 11, 6, 5. Yeah, so 5 times 13. What's 5 times 13? 5 times 3 is 15. 65, is that right? Yeah. Yeah. Okay, so now that means I got to do 44 plus 65 plus 33. What's that? 44 plus 109 plus 33. I really hope I'm right, and I am right. Okay, nice. Okay, so that's how you do it. All right, so now I know that I'm like redoing every single one of these questions right now. You don't have to. It's just I'm in a position of like I have to go over it with everyone who did it in a different way. Okay, so you can, all you have to do is choose one way. Like, I'm not gonna have you do like various ways of solving this. Now, however, if you want to see whether your answer is right, do it both ways. I mean, if you're doing it 2 different ways and you get it right, chances are you're right? The chance goes up, right? Okay, how are we doing here? Oh, man. All right, we got to get through this. So, okay. All right, let's do one of these with you guys, and then I'll let you do the next two on your own. Okay, let's see. Now, okay. So here, now, slightly different. Not that different, really, right? Here we got different shapes. And the great thing is the person who wrote this question already did some of the splitting up for you. Right? Okay, so we can go over this real quick. And then what I'm going to do is this. These two, I'm going to press pause and then do the answer key, all right, on my own. Okay, all right, so this here, these two, we got two what? Yeah, we got two trapezoids going on, right? Now, mind you, if you get this area, you got this area. There's no need to do that twice. So meaning, all right, let's look at this. Base 1 plus base 2 times height divided by 2. Okay? And then, so what is that? 46 times 12 divided by 2. All right, let me use my calculator. All right. And by the way, you can use your calculator on the quiz on Friday. Okay, let's see. What is this? 276. 276 square inches. I forgot. I gotta double this because there's two of these. So that means that takes me back to the original number, actually, which was what? 552. Okay, all right. So it's actually 552 inches square. All right, I've made this mistake more than once. Like, this is probably I don't know about you, but this is my most common mistake. I do this all the time. Okay, all right. So press pause. Do these two questions right now, and then when you come back, I'll show you the answer key. Okay, all right. All right, and we're back. So there you go. All right, through the magic of television, the answers are here. So let me just point out a couple of things. All right, what mistakes I almost made when I was solving this, and hopefully that will point you in the right direction too. So first, when I did the triangle here, the base times height, I almost forgot to divide it by 2. Okay, so it's 48, right? That's 48 times the 12. I almost forgot to divide it by 2. So what I would say also, besides knowing where to split the shapes up, is remembering all the formulas at once, right? Like, so you see why we had to spend almost like over a week just going over the formulas for these shapes, because now you can see that the goal was for you to just know that the formulas for one single shape. We're putting all the shapes together, so you have to be very fluent. All right, you have to be very fluent in all the formulas, and then because now you have to you have to really think on the fly and come up with these different formulas, and then you know what I'm saying. All right. Likewise here, the only thing I would point out is if that's 16 and the whole thing is 21, the height of this whole thing is 21. And the rectangular part 16, the rest here is 5. You see how I drew that here, right? 16, 21, the rest is 5. So that's base 1, 20, base 1 plus base 2 times the height divided by 2. That's how you get 72.5. You add it together, and there we go. Okay? All right. Tomorrow we'll practice some more, and thanks for watching. Have a good day. Bye-bye. Okay. Oh, there we go. There's the bell. All right. Don't tell me you don't miss that bell.
OMG, that was so good.